Let's dive in! Hi there, math adventurers! Are you ready for something super cool? Today we're going to talk about connections. You know how things are linked together, like you and your best friend, or your favorite ice cream and a sunny day. In math we have a special name for this. We call it a relation. It might sound a bit fancy, but trust me, it's really simple and fun to learn about. So, what exactly is a relation in math? Think of it as a way to show how things are paired up. Imagine you have a list of your favorite singers, and then you list their biggest hit songs. Each singer matched with their song is a pair. That whole list of singer-song pairs, that's a relation. It shows a connection. It tells us how singers are related to their songs. It's like a matching game for information. You actually see relations all the time, even if you don't call them math relations. Think about students in your class and their birthdays. Each student is paired with their special day. That's a relation. It connects a person to a date. Or how about different types of shoes and their sizes? Each shoe style can be paired with available sizes. See, relations are all about these connections. They help us organize how one thing links to another. So, a relation is basically a collection of pairs. We are matching one item to another item. It could be numbers matched with other numbers, or people matched with their favorite colors. It could even be cities matched with their populations. The most important idea is simply pairing. We are looking at how these items come together. They form little sets of two connected things. This is a basic idea, but it's super powerful in math. Let's look a bit closer at these pairs. Imagine you have some numbers like 1, 2, and 3, and you have some letters like A, B, and C. A relation could pair the number 1 with the letter A, it could pair 2 with B and 3 with C. So our pairs would be 1A, 2B, and 3C. This is a simple relation showing a specific link. We could make other pairs too, like 1 with C. It all depends on the connection we want to show. Relations can connect numbers with other numbers too. For example, we can have a relation called is smaller than. So the number 3 is related to the number 5. Why? Because 3 is smaller than 5. The pair would be 3, 5. Simple, right? The number 1 is related to 2, so we have 1, 2. This relation connects numbers using a clear rule. We could list lots of these pairs, 4, 7, 10, 100. It's all about how one number stands with another. Let's think about everyday objects for a moment. Imagine a relation called is the color of. We could have pairs like strawberry red, or sky blue on a beautiful sunny day, and how about grass green in the park? Each pair connects an object to its usual color. This is a perfectly good mathematical relation. It shows that math isn't just about numbers, it's a way to describe connections everywhere. Sometimes the order in these pairs is super important. Let's say we have a relation is the capital of. The pair, Paris, France, makes sense, right? Paris is the capital of the country France. But what if we said France, Paris? That would mean France is the capital of Paris. That doesn't make sense at all, does it? So we use ordered pairs. The order matters. This helps us be super clear about the connection. Okay, so now we know what relations are. They are sets of pairs that show connections. Pretty straightforward, don't you think? Now let's meet a very special kind of relation. It's called a function. Say hello to functions. Functions are like the superstars of the relation world. They are super important in math. You'll see them everywhere once you know them. They follow one extra special rule that makes them unique. So, what makes a function so, well, functional? A function, a relation, that part is true. But it's a particularly well-behaved one, you see. It has to follow a very strict rule for its pairs. Think of it like this, all kittens are cats. But not all cats are kittens, right? Similarly, all functions are relations. But, and this is a big but, not all relations are functions. This special rule sets them apart from the crowd. This special rule is what gives functions their amazing power. Imagine you have a magic machine. You put something into the machine, and then something else comes out of the machine. A function works a bit like that magic machine, but it comes with a very important guarantee. For every single thing you put in, we call this the input. You get exactly one thing out. We call this the output. Not two things, not zero things, just one. So, functions are like super organized relations. They make sure that for every starting point you choose, there's a clear, single, predictable ending point. This fantastic feature helps us make predictions. It also helps us understand patterns much more easily. If you put in a 5 as your input, for example, you know exactly what output you'll get every single time. No guessing games and no surprises with functions. This consistency is why they are so awesome in math. let's really zoom in on this golden rule for functions. It's the most important thing to remember about them. Are you ready for it? Here it is. For every input, there must be output. Think of it like a super fair candy machine. You put in 1 coin, that's your input. And you get out exactly 1 piece of candy, that's your output. Not 2 pieces, not 0 pieces, unless it's empty. 1 coin in, 1 specific candy out every time. So, if you have a set of pairs, like in a relation, and you see an input value that is paired with more than 1 output value, then alarm bells should go off. Ding ding ding. That relation is not a function. It can't be. For example, if you have the pairs, apple red and apple green, this means the input apple has 2 outputs, red and green. That breaks the golden rule. Our candy machine is confused. An apple can't be only red and only green at the same time for this rule. However, it's perfectly okay for different inputs to go to the output. That's allowed. For example, the pairs, dog mammal and cat mammal, can totally be part of a function. Here, the input dog goes to mammal, and the input cat also goes to mammal. That's fine. Each input still has only 1 output. It's like 2 different kids putting in their coins, different inputs. But both kids get a chocolate bar, the same output. This 1 output for each input rule is truly key. It's what makes functions so wonderfully predictable. It makes them reliable tools in the world of math. When you use a function, you have this certainty. If you start with a particular input value, you will always end up with the same single result. This consistency is so important for building math ideas. It helps us understand how things change predictably. It's the heart of what makes a function a function. Section 5. Picture this relations on a graph. Did you know we can actually draw pictures of relations? Yes, we can. It's super helpful and pretty cool. It helps us see what's really going on with the pairs. We use something called a coordinate graph. It has 2 main lines like a big plus sign. One line goes across, side to side, that's the x-axis. The other line goes up and down, that's the y-axis. Each pair in our relation, like 2, 3, becomes a dot. A little point on this graph showing its location. So if we have a relation with these pairs, 1, 2, 1, 4, 2, 3, and 3, 5, we can plot these as shiny points on our graph. For the pair 1, 2, we go 1 step to the right on the x-axis, then we go 2 steps up on the y-axis, and plop, we make a dot right there. We do this for all the pairs in our relation. The collection of all these dots together forms the picture or graph of our relation. Looking at these dots on the graph can tell us a lot. Sometimes the dots might form a clear pattern. Maybe they line up to make a straight line, or maybe they curve around in a nice smooth arc. Other times the dots might just be scattered about, like stars in the night sky all over the place. For any relation, no matter how simple or complex, we can represent it visually using this graphing method. Our brains are great at understanding pictures, you know? For instance, if you looked at your graph of dots and you saw 2 dots directly above each other, like 1 dot at the point 2, 1 on your graph, and another dot right above it at 2, 5, you'd know that the input value 2 on the x-axis is related to both the output 1 and the output 5. This is perfectly okay for a general relation. It just shows that 2 is connected to 2 different things. Graphing makes these connections easy to see. Section 6. Picture perfect. Functions on a graph. Now, let's use our awesome graphing skills to spot functions. Remember that super important golden rule for functions? 1 input must have exactly 1 output. No more. How does this rule look when we draw it on a graph? Well, there's a super easy and fun trick for this. It's called the vertical line test. So cool. It sounds a bit technical, but it's really simple. If you can draw a vertical line straight up and down anywhere on your graph and it hits more than 1 point, then oops, that relation is not a function. Think about why this works. It's pretty clever. A vertical line on a graph represents a single x value. That x value is like a single input, remember? If that vertical line touches 2 or more dots, it means that 1 x value, our input, is paired with 2 or more y values, our outputs. And that, my friends, breaks our golden rule for functions. So, if every possible vertical line you could imagine drawing only ever touches 1 point, or maybe no points at all, then, hooray, you've got yourself a function. Let's picture that relation we had before with these pairs. 1, 2, 1, 4, and 2, 3. Remember those? If we plot the points 1, 2, and 1, 4 on our graph, these 2 points would be sitting right on top of each other. One at x equals 1, y equals 2, and the other at x equals 1, y equals 4. A vertical line drawn at x equals 1 would hit both points. So this relation fails the vertical line test. Therefore, it is definitely not a function. Sad for it. But a different set like 1, 2, 2, 4, 3, 3 would pass. The vertical line test is like a visual secret weapon. It's a quick and easy shortcut to check for functions. If you have a graph of any relation, big or small, you can immediately tell if it's a special function, just by imagining sweeping a vertical line across it. Does it ever hit more than one point at a time? This graphical check makes identifying functions much clearer. It's less about abstract rules and more about seeing it, and seeing things always makes math more fun. Section 7. Functions all around us, real-life examples. You might be sitting there thinking, okay, functions are special relations, they follow a strict rule. I can even spot them on a graph with a vertical line. But where will I ever use this stuff? Well, guess what? Functions are absolutely everywhere. They are hiding in plain sight in your daily life. You use them all the time without even realizing it. They describe how one thing depends on another thing in a very predictable and reliable way. Let's see. Think about your favorite vending machine at school or the mall. You press a button for a specific snack or drink. Let's say button C5 is for your favorite chips, your input. The machine then gives you that specific bag of chips, your output. For each button you press, each unique input, you get exactly one type of snack, one specific output. If button C5 sometimes gave chips and sometimes gave pretzels, it wouldn't be a very good vending machine, would it? That's a function in action right there. So cool. Here's another super common example. Your age. For any specific person you can think of, that's the input, there is exactly one current age for that person, that's the output. It's not possible for your best friend to be 10 years old and 12 years old at the exact same moment. Each person is uniquely matched to their current age. So, the relationship that connects a person to their current age is a perfect example of a function. See? Functions describe basic facts about our world. How about the temperature outside during the day? At any specific time of day, that's our input. There is exactly one temperature reading, that's our output. At 9 a.m. it might be 65 degrees Fahrenheit. It cannot be both 65 degrees and 70 degrees at exactly 9 a.m. at the exact same place. So, the temperature at a specific location as it changes over time can be thought of as a function of time. This is super useful for things like weather forecasts. Section 8. More real-world fun with functions. Let's keep exploring and find even more everyday scenarios where these amazing functions pop up to say hello. Consider the cost of buying several identical items, like when you go to the store for your favorite pencils. If one pencil costs 50 cents, then the total cost depends on how many pencils you decide to buy. If you buy one pencil, input, the cost is 50 cents, output. If you buy 3 pencils, input, the cost is $1.50, output. For each number of pencils, there's one specific total cost. This is a function. Think about when you're riding in a car or on a bus. If the car is traveling at a steady, constant speed, say 30 miles per hour, nice and easy. The distance you travel depends on how long you've been driving. After 1 hour of driving, input, you've traveled 30 miles, output. After 2 hours of driving, input, you've traveled 60 miles, output. For each amount of time you drive, input, there's exactly one specific distance covered, output. This is a type of function called a linear function. What about converting measurements from one unit to another? For example, converting inches to centimeters. There's a specific rule or formula for this conversion. For every length in inches you start with, your input, you get exactly one corresponding length in centimeters, your output. 1 inch, input, is always 2.54 centimeters, output. It can't be 2.54 cm sometimes and 3.0 cm other times for that same 1 inch input. It's a reliable function. This makes sure everyone gets the same result. Even something as simple as cooking can involve functions. Imagine you have a recipe for cookies. The recipe might say, for every 1 cup of flour, input, you need to add 2 eggs, output. So if you use 2 cups of flour, a different input, you would need 4 eggs, a different output. For each amount of flour you decide to use, there's a specific number of eggs the recipe calls for. This relationship between ingredients is a function. It helps make sure your cookies turn out yummy. Section 9. Why bother? The superpower of understanding relations and functions. So, we've journeyed through the world of relations. These are the pairs that connect all sorts of things. And we've met their super special cousins, functions. where each input has only one unique output. You might still be wondering, okay, this is neat, but why is understanding all this stuff so important in math? Well, getting a grip on relations and functions is like getting a secret superpower in mathematics. It's a fundamental building block for so many amazing topics. Functions are incredible tools that help us model the real world. Think about scientists, engineers, and even game designers. They all use functions to describe how things change. They use them to make predictions about the future, and they use them to solve really complex problems. Whether it's figuring out how a plant grows over time, or how a character jumps in your favorite video game, or even how to bake the perfect cake with an oven's temperature, functions are the mathematical language they use. As you continue your awesome math adventure into subjects like algebra, geometry, and even calculus later on, functions will be absolutely everywhere, like friendly guides. You'll learn how to draw graphs of different kinds of functions. You'll learn how to combine them in cool ways. You'll even learn how to go backwards with them. They are the language used to describe change and relationships. Without a good understanding of functions, moving forward in math would be much, much trickier. Ultimately, understanding relations and functions does more than just help with math. It gives you a new way to think logically and spot patterns. It's not just about memorizing rules from a textbook, it's about understanding how things connect in a reliable way, and how one thing can predictably determine another. This amazing skill is valuable not just in your math class but in solving all sorts of puzzles and problems in everyday life. So, embrace relations and functions as your math buddies. They're here to make even complex ideas easier to understand.